Welcome back, everyone. Today, we're exploring the anatomy of control, the really complex, kind of beautiful taxonomy of industrial valves. If you're designing fluid systems, working out there in manufacturing, or honestly, if you just want to understand the hidden mechanics running, well, pretty much our entire modern infrastructure, you're in the exact right place. We're going to decode the whole landscape of these absolutely vital components today.
Okay, so let's kick this off by establishing the golden rule of industrial fluid dynamics. It's an old saying, but it hits the nail on the head. Know your valve, select right, operate safe. And look, the stakes here are incredibly high, right? Picking the wrong component isn't just, a minor headache. It can literally lead to massive system failures or catastrophic safety hazards. You've got to know exactly what you're putting into that pipeline.
So, to avoid getting overwhelmed, here's our roadmap for this explainer. First, why industrial valves matter. Second, the primary flow controllers. Third, regulation and safety valves. Fourth, specialized valve types. And finally, operations and materials.
Let's jump right into Section 1, Why Industrial Valves Matter. I like to think of valves as the ultimate traffic cops of the industrial world. They're out there constantly directing flow, making sure speed limits are obeyed, and ensuring that volatile materials don't end up where they definitely shouldn't be. Honestly, they are the only thing preventing catastrophic pileups and maintaining absolute order in these crazy high-pressure systems. At the end of the day, it all boils down to these 6 core jobs. These components actively control flow, regulate high pressure, and manage temperature. But beyond just moving fluids around, they're literally there to ensure human safety, protect your massive equipment investments from bursting, and ultimately keep those long-term maintenance costs down.
Moving on to Section 2, the primary flow controllers.
So let's look at the heavy lifters. We're talking about the 4 primary categories: gate, globe, ball, and butterfly valves. These are the fundamental architectures you're going to run into most often out in the field, and each one is designed with a really specific mechanical approach for, opening and closing the pipe's throat. But within these broad categories, you have some highly specialized subtypes. Take gate valves, for instance. You've got your standard rising and non-rising stems, sure, but also the knife gate valve. It's practically razor sharp, perfect for cutting right through thick, sludgy slurries. Or check out the ball valves. They range from simple 2-piece setups all the way to heavy-duty trunnion-mounted ones for serious high-pressure situations. Every single variation tweaks the core physics just a bit to handle completely different flow characteristics. It's pretty brilliant.
All right, Section 3, Regulation and Safety Valves. Next up, we have the engineering solutions meant specifically for backflow prevention and pressure buildup. We're talking check valves, plug valves, pressure relief and safety valves, automated control valves, and reducing valves. At this point, they aren't just directing traffic anymore, they are the active guardians of your pipeline. And the sheer variety of safety nets here, it's just wild. Under check valves, which, remember, only let fluid flow in one direction to stop dangerous backflow, you have swing, lift, and dual plate designs. Then you've got the absolutely critical pressure relief category, featuring the classic safety valve with a lever. We even see highly specific reducing valves, engineered purely for dialing back temperature or steam. It's basically a massive arsenal designed entirely to keep your operations safe and totally predictable. That brings us to Section 4, Specialized Valve Types.
So, what happens when you face incredibly unique industrial problems? Well, we turn to the specialized tools: diaphragm valves, strainer valves, and a catch-all category for special-purpose valves. These are purpose-built units for those times when off-the-shelf hardware just isn't going to cut it. Notice how something like the basket-type strainer or the pinch valve looks wildly different from the standard stuff we covered earlier? That's because their jobs are incredibly niche. The strainer valves are designed to physically catch solid debris without completely choking the system. Meanwhile, the pinch valve, it uses a flexible tube that literally gets squeezed shut. It is an absolutely brilliant way to handle highly abrasive or corrosive fluids that would otherwise just eat right through standard mechanical metal parts.
And finally, Section 5, Operations and Materials.
Now, let's talk about how we actually manipulate these things. Valve operation scales all the way from simple human-powered components up to heavy-duty system-actuated setups. On the manual side, you've got the classic hand wheel, the really fast quarter-turn lever, and the gear operator when you need some extra mechanical advantage. But as modern systems scale up, we shift over to actuated operations. That's where pneumatic, electric, and hydraulic power take over, letting a control room operate a massive pipeline grid remotely with absolute precision. a real game changer.
And we can't forget what they're actually made of. Whether you're piping basic water or literally boiling corrosive acid, there's an exact chemical match for your materials. You've got standard steels and iron, highly resistant stainless options like 316, non-ferrous bronze and brass, super versatile plastics, all the way up to ultra-high-performance duplex and super duplex alloys. You basically fit the metal, or the plastic, perfectly to the mission.
Which brings us to our final thought for the day. With so many variables in play here, from primary flow controllers and specialized diaphragm shapes, all the way to high-tech super duplex materials, which valve combination is safeguarding your operation right now? It's kind of incredible to step back and realize how much we rely on these hidden mechanical heroes. I mean, every drop of water, every cubic foot of gas relies on this intricate taxonomy working perfectly behind the scenes. Thanks so much for learning with me today, and I'll catch you on the next explainer.